All right. So, section 1.5b, we're going to still deal with inverses. Okay. So, if we look at an inverse, if y equals x squared, okay, what points does y equal x squared involve? Well, 0 and 0, 1, 2, 3, negative 1, 1, negative 2, negative 3, and so on. Okay? So, zero, zero, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. Looks like that. Okay? Somebody want to shut off the light switch on that side, so then it shuts off the front light so you guys can see a little easier. All right, so if f of x equals x squared, f inverse of x equals what? Well, what you do is you change the y and the x around. So x would equal y squared, and if you solve for y, how do you get y alone? Square root. So y equals the square root of x, okay? So that would be the inverse, okay? Now, a way to find the inverse from a graph is, you see how we switched around y and x here? Well, you just switch around y and x here. So 0, 0, 1, 1, 4, 2, 9, 3. 0, 0, 1, 1, 4, 2, 9, 3. Looks like that. Now, you'd think it'd look like this too, but if this is a function, okay, this one, you cannot have 1. If you put in the square root of 1, you're going to get 1, okay? You're not going to get negative 1 down here, okay? So it's not in the domain. So the domain of this is basically 0 to infinity, okay? The domain of this is negative infinity to infinity. So let's change back to red. Negative infinity to infinity. So their domains are slightly different by what you can use, okay? So let's say you started out with like y equals the fourth root of x, okay? So the fourth root of 0 is 0. The fourth root of 1 is 1. The fourth root of, let's say, 16 is 2. And that's all the further we're going to go. Okay? So if we look at this, this is our original function. So let's make it in function notation, I guess. So we go 2, 4, 6, 8, 10, 12, 14, 16. And we can go by ones here. So 0, 0, 1, 1, 16, 2 looks like this. Okay? Its domain goes from 0 to infinity. So when we do the inverse of this one, okay, f inverse of x, then we switch the y and the x around. So before y was equal to the fourth root of x, now x is equal to the fourth root of y. How do I get y alone? You take each side to the fourth power. So y would equal x to the fourth. So x to the fourth is the inverse. So if you make an xy chart, 0, 0, 1, 1, 2, 16. 0, 0, 1, 1, 2, somewhere up here, 16. So it goes like this. Okay? That's the inverse of it. Now, the inverse doesn't go this way because since we originally started with this domain, the inverse cannot gain more domain. Okay? So the domain of this would also be 0 to infinity because we're not going to gain extra domain. So if there's something that limits the domain in the original function, that domain is still limited in the inverse. Okay? All right. So it's an inherited domain. So if you're limited with their inherited domain, you're limited. Now, a little review from last time. Is this a function? Yes. Is it a 1-to-1 function? And the answer is no. To be a function, it has to pass the vertical line test, which it does. To be a 1-to-1 function, it must pass the horizontal line test, which it doesn't. Okay? If it's a 1-to-1 function, it has an inverse. If it's not 1-to-1, it doesn't have an inverse, or we limit the domain where it has an inverse. Okay? The domain is limited for whether it has an inverse. Okay? So you have to tell whether functions are 1-to-1 or not and figure out the graphs of the function. Okay? Take another one. Let's say let's go f of x. F of x equals x plus 1 over 3. Okay, let's graph that. Well, I'm going to graph the point 2 because that goes in evenly. 2 plus 1 is 3 over 3 is 1. I'm going to graph the point 5 because 5 plus 1 is 6 divided by 3 is 2. So those are points. I'm going to graph the point -1 because -1 plus 1 is 0 over 3 is 0. So if I graph those points, the function -1, 0, 2, 1, 5, 2 is just a diagonal line going like this. Okay? It's inverse. So to find the inverse, you go x equals y plus 1 over 3. What's my first step to get y alone? Multiply by 3. 3x equals y plus 1. And then subtract 1. 3x minus 1. Okay? If I put in a 1, what am I going to get? 2. If I put in a 2, what am I going to get? 5. If I put in a 0, what am I going to get? Notice how if you just flip around these numbers, 0, -1, 1, 2, 2, 5. Inverses reflect around the line y equals x. See how it's a reflection over that line? Okay. So this reflects to there, that reflects to there, that reflects to there. That's a reflection, or you can just think about it as those points switch around. Okay? And that's how you find an inverse. Okay? Those are different ways of looking at inverses. Right? So today, we're working with inverses. Now, if you multiply inverses times each other, so we have f of x equals, or not multiply them by each other, but do composite function of inverses. So f of x is x plus 1 over 3, and the inverse of x is 3x minus 1. If you do f of f inverse of x, okay, if you put this into here, which is what we're saying there, 3x minus 1 plus 1 over 3 gives me, what's 3x plus 1 minus 1? 3x over 3, which gives me x. If you take f inverse of f of x, then let's put 3 times x plus 1 over 3 minus 1. Well, the 3's cancel, and x plus 1 minus 1 is what? X. If terms are inverses of each other and you do their composite function, they should both wind up to be x. Okay? So that's the basics of everything you need to know to complete this section on inverses. I think there's only 9 problems to do. So there's not that much to do on this first section, and then we'll talk about transformations in the second section.